Hello and welcome to the SOL review of A.05c, System of Inequalities. Now, this is kind of similar to system of equations, where you can actually graph a system of equation to find the answer. However, we don't care about the area of intersection or the point of intersection at this point. We're actually going to care about an entire shaded area. So what I want to do is I'm going to go ahead and mark this with my blue pen. I'm going to mark this with my pink pen here. We're actually going to graph both of these inequalities. This will be a good refresher on how to graph an inequality that has an x and a y, and it'll also just be a good refresher on how to graph. So what you always start with is the y-intercept. That's the term that's being added or subtracted, and it always should be in this form. I'm going to put it in parentheses, y equals mx plus b. And you might be saying to yourself already, whoa, we don't have an equal sign. That's fine. I'll show you what's different about it in a minute. So we're going to start with positive 1. That's where our y-intercept is. So I'm going to make a mark on the y-axis, just a refresher. This is the y and that's the x. So I made a mark, and our slope is 2 over 1. So that means I'm going to go up 2 over 1. Up 2 over 1. I could probably sneak in one more. But you'll notice it's in a straight line. I can even go backwards. Instead of up 2 and right, I can go down 2 and left. And it still ends up with about the same process. So we get a nice straight line. This is of course made a lot easier if you have graph paper, but unfortunately don't really have that available. That's my best attempt at a straight line today. Alright, now I've already made one small mistake. If you noticed, I made the line solid, but in our example there's no bar underneath. So one thing we kind of need to remember here is if it's greater than or less than with no bar underneath, it's going to be a dashed line. You can think of it like it's not included, so you don't include the wall, so it's not really part of it. However, if it had a bar underneath, that would be a solid line. So in fact, if I could I'm going to use a Sharpie here to cover it up, so it should really look something like that. That looks pretty. Alright, so I'm going to switch to my pink pen, and I'm going to show you how to graph this one. Just same steps. So positive 3, 1, 2, 3. And then the slope is negative 1, because that's a number, negative 1, over 1. So we would go down 1 and over 1. So we're just going to keep going down 1 and over 1, down 1 and over 1, till we get enough to make a pretty straight line. Now this is a solid line. Ooh, missed that graph a little bit. See? It's a lot easier when you have graph paper. Alright. Now, you might be saying, whoa, you just graphed an equation, and I would agree, but here's where the difference of the inequalities comes in. If you go back to the blue problem for a second, it says y is greater than the line. And, 2x plus 1 is what we actually graphed. So y is greater than the line. That means any value that's greater than the line, any y value that's above, greater than, above, more. So anything that's above is actually a shaded area. So what's going to happen is any point I pick from here is actually a solution to that inequality. So for instance, it looks like I could pick the point negative 1 and 1. Let's plug it in real quick and see what happens. So let's see. Y is greater than 2x plus 1. We're going to plug in negative 1, 1. Let's see what happens. So 1 is greater than 2 times negative 1 plus 1. 1 is greater than negative 2 plus 1. Hey, look, 1 is greater than negative 1. It's true. If I were to plug in a point that wasn't over there, like, for instance, 0, 0 is a very easy point to pick. Ready? Here we go. Y is greater than 2x plus 1. 0 is greater than 2 times 0 plus 1, which is just 0 is greater than 1. 0 is not greater than 1. So you know now why I shaded this side. It's because this is any point I pick from over here is going to be a solution for the blue equation. Let's do the pink one. Pink one says y is less than or equal to the line. So less than, below. So we're going to go ahead and shade below the line. Some really good shading job, I know. It's exactly why I went to college. Really worked on my art skills, I swear. Alright. So where exactly is our answer in all this mess? Well, if you notice, we have a blue shaded area, and we have a pink shaded area, we have a non-shaded area, and then we have an area where it's both blue and pink. This would be our answer. So anything in this region, that's our solution area. if I pick a point out of there, for instance, like if I picked, I don't know, right here, -3, 1, it would actually be true for both inequalities. So it's considered a solution to the system of inequalities. Let's go ahead and take a look at an SOL example. All right. So, for which system of inequalities is -3, 1 a solution? And just a friendly reminder, this is x and this is y. So what you're going to do, it's kind of similar to checking your answer to system equations. Actually, it's not kind of, it is similar. You're just going to plug in the value and see where it holds true. It's got to be true for both inequalities. If it's only true for one, no dice. It's got to be true for both. So here we go. Let's go ahead and clean this up a little bit. So it's going to become -3 plus 1 is less than -2. And when I clean this up, -2 is less than -2. Well, no, -2 is -2, and since this doesn't have a bar underneath, it fails, so it's not A. All right, I can move on to the next one. Makes life a little easy. Well, wait, actually, I don't even have to do it. It's the same inequality, so I already know it failed. So this fails again. Save yourself some steps. All right. If you notice, it looks like the same inequality, but this time they were smart and they put the bar underneath. So this has potential to hold. Let's see. -2 is less than or equal to -2. So it's true for the first inequality. Let's see if it holds for the second one. So 2 times -3 minus 3 times 1 is less than -9. 2 times -3 is -6. -3 times 1 is -3, is less than -9. Well, when I clean this up, -9 is less than -9. And we run into the same situation we had before, where there needs to be an equal bar underneath. Since that doesn't exist, it doesn't work for this one. All right, so our final problem, this better hold true. Well, we know the first one works because we already checked, so I'm not even going to bother with it. I did the work, and you can see it there. Let's do the second one. So 2 times -3 minus 3 times 1 is less than or equal to -9. I think this has a good chance of working. -6 minus 3 is less than or equal to -9. And -9 is less than or equal to -9. It was true for both, therefore the answer is D. Thanks for watching.